Hi, we are the Covenant Christian Academy Advanced Solar Car team, and this is our oral presentation. Historically, we drove from Colleyville to Mineral Wells to build our solar cars. This is a 2.5-hour, 130-mile round trip that often was quite a barrier for most students. In 2019, we lowered this barrier by moving our solar car shop a mere 3 miles from our school. We now have a total of 9 new students for a total program size of 12, which was made possible by having the new shop just 3 miles from our school. Historically, CCA's solar car program has been a club activity that was solely parent organized and sponsored, and students received no school elective credit. Starting with 2021, a dedicated teacher has been assigned who will begin to lead the program starting in 2022, and a student elective credit has been created. During the design and construction phase, all CCA solar car students serve as part of a larger team, where all team members are involved in both the advanced and advanced classic cars in order to further build their skills. During the race event, the 12th grade team is organized into a senior varsity team with the advanced division car, while all other students will be organized into a junior varsity team with the advanced classic division car. In 2019, we built an aluminum monocoque car, which placed second in the division. However, the car's solar array power was down nearly 20% compared to our design expectations, and we soon realized that our modules had potential reliability concerns as well. So for 2021, our principal objectives are to evaluate and resolve the nearly 20% solar array derate problem, as well as evaluate and resolve module reliability concerns. For our engineering analysis of the solar derate problems, we utilized an infrared camera, infrared thermometer, and pyrometer to understand the actual operating conditions. We manually constructed the maximum power point for each subarray and compared it to the temperature and irradiance adjusted expected values. Finally, we compared the individual subarray production when isolated from the others to the combined production with all subarrays in service. From this, we concluded that the individual AERL controllers were fighting against each other and significantly derating subarray number 3. Notice the relatively high temperature in the photo. Finally, the AERL controllers didn't seem to be doing a good job in their maximum power point tracking role. It didn't seem to tune effectively. During testing, an internal module fault occurred on subarray number 5, which rendered it useless. For our engineering analysis of module reliability concerns, we disconnected the solar array from the car and transported it nearly 2,200 miles round trip to the SBM Solar Factory in Concord, North Carolina for testing. Once there, SBM Solar conducted both IV trace testing and electroluminescent testing. From this, they concluded that the module fault on subarray number 5 was caused by insufficient insulation between the module buses during the custom module manufacturing process. Additionally, SBM concluded that all of the modules were at risk faulting due to the same design flaw. SBM initiated a high-risk repair plan for each module.
The first of our engineering decisions is about the solar modules. Cell damage was caused by SBM Solar during repairs. SBM Solar damaged the cells around the perimeter of the modules when removing them from the array frame with a putty knife. This resulted in a 10% reduction in their tested rating. The damage can be seen in the dark parts of these images. The bottom line is, the high-risk repair conducted by SBM Solar resulted in additional consequential damage, making these modules effectively no longer competitive for the advanced division race. Due to these now unrepairable SBM Solar modules, a tough economic decision was made to purchase an entirely new set of solar modules from Shine Solar. We have purchased 6 new modules that total 1989 watts, or 546 cells. The new modules have arrived at our shop and new array construction is underway. The second of our engineering decisions is about the solar charge controller. For the reasons previously outlined, we chose to abandon the AERL charge controllers and purchase a commercial scale charge controller called iPanda Galaxy. The iPanda can accommodate all 6 of the solar modules wired in series and eliminate the 20% or so power derate that we experienced in 2019. The trade-off for this approach, however, is that the iPanda unit is bulkier and weighs 12 pounds more, but it is a trade-off that we are willing to make.
For a mechanical drawing, we would like to point out 3 specific areas. The body and frame is an aluminum monocoque construction. The side crush zones are filled with hexel honeycomb and distribute impact forces into the bulkhead both in front of the driver and behind the driver. And lastly, the suspension, roll bar, and upper crush zone are the only components on the car made of steel.
In our high voltage schematic, you can see our 6 solar array modules aligned in series that come at 1989 watts. Our iPanda Galaxy unit here, our 96 volt lithium ion battery pack in the bottom right corner, and our Mitsuba 2 kilowatt hub motor in the bottom left corner. For our low voltage schematic, nothing has changed from previous years since the requirements have not changed.
And from a design and construction standpoint for the new solar array frame, the perimeter frame rails and the long metal bar for our array frame was created using a 2-inch by 1-inch rectangular aluminum tubing, and for the crossbar, as you can see here, were created using a circular aluminum tubing that was 3 1/4 inch wide, and they were all held together using aluminum brazing, as you can see in these 3 pictures.
Construction for the solar charge controllers and their replacement is shown here. You can see us taking out the AERL charge controller in these images, and we have begun replacing them with the iPanda unit.
So pre-pandemic, our team was able to raise $20,000 in outside funds, but due to the delays encountered by the pandemic, we were unable to complete all the necessary modifications to our advanced division car. But we will do so and perform all the necessary testing in the 2 to 3 weeks leading up to the race. Thank you.